A periodic function repeats its values in regular intervals. Some of the most well-known periodic functions are y equals cosine of x and y equals sine of x. Pictured below are one cycle of the function cosine x and one cycle of the function sine x. Note that for each of these functions, there's a repeating pattern. And once we've gone through all the different positions of that pattern and we get back to its starting position, then we've completed a cycle. Now, when we use periodic functions in real-world applications, it's important to think about the dimensions of the function's input. For example, is the function a function of time? If so, then the time of a complete cycle is called the period t of the function. But if we have a function of position, then the length of a complete cycle is called the wavelength, lambda. The amplitude of a periodic function is half the magnitude of the difference between the function's highest and lowest values. For many functions, amplitude is actually quite easy to identify because it will be in the formula of the function itself. It'll be the number that's multiplied on the outside of the sine or cosine function. And the amplitude can also be thought of as the height of a wave crest from the baseline, or it could be thought of as the depth of a wave trough. Here we'll make a sketch of periodic functions and then determine the amplitude of the functions. So this first one requires that we know what the sine function looks like. Now sine starts at 0, and then it returns to 0 after a cycle of 2 pi. It has a maximum height of 1, and it will cross through 0 at pi, and then it will go down to -1, and then come back up. And the function will repeat with that pattern. Now that is y equals sine of t. What we need though is y equals 3 sine t. So all our output values are going to be multiplied by a factor of 3. This has the effect of making the sine wave 3 times as tall. But all the other features remain the same. It's going to have the same period and the same shape. Okay, so what is the amplitude of the y equals 3 sine t function? The amplitude is 3. That is the height. That is the height of the crest. And it's also the number that is attached to the sine function. This next one requires that we know what the cosine function looks like. Cosine starts up at 1 at time 0, and after a cycle of 2 pi, it's going to return to that same position. It'll oscillate to a -1, and it'll also cross 0 at these points here. It'll look like this. And the pattern will continue. That is y equals cosine t. Now we have to transform the function though. And they say they want a -1 on the outside of the cosine. This is going to have the effect of inverting the vertical values. So our function will look like this. Okay, and this is y equals negative cosine t. Now the amplitude will still be 1. Amplitude is just a positive value or absolute value. Now let's see, we're going to do -1/2 sine t. Alright, so whereas sine t looks like that, we need to both cut the amplitude in half and invert the values. The amplitude here will be 1/2. Okay, cosine looks like that. But we're going to double it in amplitude. And we'll also do a vertical shift this time, raising each value up by 1. That's going to move our baseline from here to here. We can now draw the cosine curve. Okay, so what is our amplitude though? Our amplitude is 2. It is the absolute value of the number attached to the periodic function.